So for this first review section, practice 1, working with algebraic expressions, mathematical models, and real numbers. There are lots of objectives here. A lot of these should sound familiar, definitely with evaluating algebraic expressions. So this is eventually going to be nicknamed just plug and chug, because we'll have some number that we just want to plug into some type of equation using mathematical models. We'll also see that. We'll see two new terms that I don't think get talked about too much, and I think it's pretty easy with the intersection and the union of two number sets, recognizing subsets of the real numbers, so taking an intersection or a union of two sets that are given, using inequality symbols a little bit, also evaluating with absolute value, which again, if you need a refresher, is just the distance on a number line. So we have that from Algebra 1 and Algebra 2, using absolute value to express distance, which is kind of tying into this definition here, identifying properties of real numbers, and also simplifying algebraic expressions. So this first example has us evaluating an algebraic expression, so tying into that first objective, where we're just being given this equation here, 3x plus y, and we're dividing that with x minus 1, where they're saying x is negative 4 and y is 2. So this is pretty simple. It's saying that wherever x is, we want to write in negative 4. Wherever y is, we want to put in 2. I'm using parentheses so that hopefully you can see where everything's coming from, or that is a new number that we're putting into the mix. We also have another x down here and then deducting 4. So going from left to right, we have this first product here of 3 and negative 4. So we have negative 12, adding on 2, dividing by the difference, so subtracting 1 from negative 4, so going more negative to negative 5. We can then simplify the top part. Negative 12 plus 2 gets us negative 10, keeping negative 5 in the denominator. When this is simplified, take a moment, think, how can this be simplified? If we're taking a fraction, and both terms are negative in the top and the bottom. Hopefully you're going for negative 2, which is our final answer. Those ones aren't too bad. Just be careful with combining like terms, knowing when to add, subtract. For 2, we're being given two different sets. So what it means by a set is really just a group of numbers. Sometimes they have a common characteristic. Sometimes they are just miscellaneously plucked out of the air. So the idea of a set is really just a group of numbers. So we see here that we have one set and an additional set where the inside numbers are different. As mentioned from the third and the fourth objective, we'll be using the intersection and the union of two sets. So with the intersection, it sounds just like you think it would. If it's an intersection, it's as if you're comparing and contrasting these two sets to see if there's anything in common. So when you see the I, think of intersection, think of it like driving, like they're going to intersect. So you're thinking, what numbers are in both sets? If you look closely, this has 10, 12, 14, 16. This has the odd numbers. Hopefully you notice that pattern too, of 9, 11, 13, and 15. So unfortunately, there's nothing in common. So we could say that we could use this symbol, which implies the empty set. And that's saying that there are no numbers in common. All the numbers from this first set are unique, and they do not see another, like we don't see another 10, 12, 14, or 16 over here. So we say that there's nothing in common, or we say that it's an empty set. And this symbol comes up every now and again, and that also implies empty set. For the union, what this does is it joins the two sets. So think of this, it's a union, uniting, it's bringing them together. So this brings together sets. So we see that we have 10, 12, 14, 16 again, also the odd numbers. We are just bringing them together into one set, and luckily there are no repeats. So we can just begin to write this as is, and I'll go in chronological order from least to greatest. So we see 9 first, 10, 11, we see 12, 13, 14, 15, 16. And I was crossing out the numbers along the way just to make sure that I have all of them. So this would be considered the union of these two sets. Union was a new term that's coming into play. Intersection is also a new term. And luckily these terms you should have heard of before, so you can bring in that idea. For the back, rewriting with absolute value bars. As mentioned previously, this measures the distance to 0. Zero on a number line. So some examples here. We were taking the absolute value of 10. Well, that's just 10 units away, so that would be rewritten at 10. We were taking the absolute value of -7. Although this is a negative number, the absolute value as far as distance goes would be +7. So notice this is always going to turn out to a positive number, even if the input's negative. Seen here, we have a little bit to work with. So if we look closely, although we have absolute value brackets on the outside and then 2 more inside, these 2 numbers we can evaluate. So if we have the absolute value of -4, we can rewrite that to +4. We're then deducting the absolute value of -8. So we're really just deducting 8, keeping the outside brackets there. 4 minus 8, you know that is -4. So really you're taking the absolute value of -4, which is just 4. We'll make that positive so that you know the outcome has to be positive. With 4, a little bit of combining like terms. Again, with problems that have a lot of parentheses going on, I always focus in towards the middle. So I'm trying to think on the broader term of things, like is there something more closer in that's in parentheses that I can evaluate? So hopefully you're noticing really this 6 minus parentheses 3y minus 2. So since we're subtracting this entire binomial, we should be thinking of that as 6, definitely deducting 3y. You can kind of think of this as distribution. So we're deducting 3y, and we're also deducting this -2. So you can think of this out as deducting -2. Since we're subtracting a negative number, hopefully you're thinking of this as +2. So that's what we should be bringing into the mix here. Just to rewrite the rest. Hopefully you notice that the 6 and this 2, underline this so that you see, the 6 and this 2 are common terms. They share no variable, but they are constants, so we have to combine those. So with 6 and adding on 2, this should give us 8. -3y is still along for the ride. The reason that they use brackets in this case is not to try and confuse you with the absolute value problems that we saw up here. It's really just another way that they could write or interpret parentheses. I guess it's just to show that this is still something you want to focus on. So with 3 on the outside, hopefully you're thinking of distributing. Once more, if we are distributing 4 we're distributing negative 3 to 8. I think this will make our life easier. So notice negative 3. So we can think of this still as 4 in the front, but negative 3 times 8 should get us to deduct 24 with negative 3 distributing to negative 3y. Think of that as positive 9y. So down here, I'm just showing the work on how I got to this. Eventually, if we take this further, only things that we can really combine here are going to be this 4 and this negative 24. So if we have 4 and we take away 24, it's really deducting 20. 9y is on its own. And that's our final answer. So what's nice about this first section is that hopefully some of this material does sound familiar. What's cool is that since this is a video, you can watch this as many times as you need to. The main thing about these videos is that you can go back, look them over, check them, make sure everything looks good. If you get stuck on anything, of course, come into class and let me know. But please make sure that you're filling in your notes along the way so that you can get credit for this video. And of course, if you have any questions, please let me know in class. But this first section should be pretty much a refresher, so I don't think there's anything too new here. And of course, if you have any questions, please let me know in class or shoot me an email.